Hi, 7th period. I'm making this transformations video for the Unit 3.5 Day 4 notes because sadly I was muted and I'm so sorry, e-learners. I try really hard not to let that happen, but hopefully this video is coming out in time so that it'll help you. So to begin with, we are gonna do transformations of a linear parent function. So the two things we need to focus on here is this word transformations and the idea that we are working with linear parent functions. So there is only one linear parent function. And if I read this sentence, it says, the simplest form of a linear function is f of x equals x, which we refer to as the linear parent function. So that is the linear parent function. All other linear functions, such as g of x equals 2x, or j of x equals x minus 3, are referred to as transformations of the parent function. So that might seem a little complicated, but let's break it down baby steps. The first thing I need to look at is here. The parent function, f of x equals x. We call it the parent because this is the most simplest form of this function. Everything else just kind of comes from it. So if we remember, f of x is the same as the variable y. So if we rewrite f of x as y, then we could say f of x equals x is the same as y equals x. So if I take a look at this graph, y equals x. This is the line y equals x. And it makes sense because I know when I'm looking at the parent function y equals x, well, the y-intercept, that's at 0. The x-intercept is also at 0 because y equals x, my parent function, goes through the origin, and the slope of this parent function is up 1 over 1, up 1 over 1. So I know my slope, rise over run, is 1 over 1, or just 1. So this is the function, this is the line that we are going to transform over and over and over again. So every time I see one of these graphs, it has y equals x, y equals x, y equals x, y equals x. And what we're doing today is transformations of y equals x. So transformations mathematically, and especially on graphs, it means we're changing something. Transforming is to change. So the transformations mathematically, in this case, we're going to be moving up and down and stretching and shrinking our graph. So let's look at what that looks like. So if I have the transformation g of x. So that is our transformation function. What are we transforming? Always, always, over and over again, we are transforming the parent function, which we set up here is f of x equals x. But we know that this is the same as y equals x. So this line, y equals x, right here, we are going to transform it. How? We are going to take f of x, which we know is y equals x, and we are going to add 2 to it. So the way that we can think about this is the transformation function g of x is f of x plus 2. But we said f of x is the same as y, and y is equal to x. So we're really taking g of x is the transformation function of all the x values of the parent function plus 2. So what that looks like on a table is, well, if I look at my favorite x values, -2, -1, 0, 1, 2, and if I plug those in for x, then that's going to give us -2 plus 2, -1 plus 2, 0 plus 2, 1 plus 2, and 2 plus 2. So over and over again, we're taking my parent function and adding 2. So this whole line, we're adding 2. So that means the new function is going to have y values of -2 plus 2 is 0, -1 plus 2 is -1, 0 plus 2 is 2. Wait, hold on. Am I losing my mind? Yeah, yes I am. Yes, I am. Negative 1 plus 2 is positive 1. There we go. 2 minus 1 is 1. 2 plus 0, or 0 plus 2, is 2. 1 plus 2 is 3. And 2 plus 2 is 4. So what I see is I'm taking my original function, which would have this parent function at negative 2, negative 2. I shifted it up 2, and now it's at 0. So I have the new y coordinates 0, 1, 2, 3, 4. And we know as a table, these are just coordinates, so I could rewrite these off to the side. If x is negative 2 and g of x, which we can think of as our y, is 0, then the coordinate is negative 2, 0, negative 1, 1, 0, 2, 1, 3, and 2, 4. So if I plot all of these points, well, let's see what happens. My new line, f of x plus 2, will be negative 2, 0, that's here. Negative 1, 1, that's here. 0, 2, that's here. 1, 3, 2, 4. So notice my slope stayed the same. I'm still going up 1 over 1, up 1 over 1. But my entire line, every point on this my original red line, every point on my original parent function has been shifted up 1, 2 units. So this plus 2 here, f of x plus 2, my parent function plus 2, does exactly that. It takes the entire line and moves it up 2. So we say the transformation here is adding 2. So adding 2 move the line up 2. So without even filling in this table, if I know that adding 2 moves us up 2, I can see that subtracting 2, well, that should move us down 2. So take my entire line, my entire original red line, and just move it down 2. So now the slope is the same. I didn't change the slope, so it's still up 1 over 1, up 1 over 1. The same slope of that line, but I shifted the entire thing down 2 units. Okay. And one way I could visualize this is my favorite app, Desmos. We said our parent function is f of x equals x. Okay, and that's y equals x. But if we're transforming it, to the new function, g of x is my original f of x plus, I don't know, some number. It could be any number. Let's say a for general, because I could add in a slider now, which is fun. So if a is 1, that's f of x plus 1, so it goes up 1 unit that we can see here. But what if we move it up that much? To 4, then I've moved it up 4 units. And I could go lower by subtracting, I can go higher by adding. So this is what's happening. Anytime we're subtracting, I'm going down. Anytime I'm adding a positive number, I'm going up. So, describe the effects of the linear parent function f of x when adding or subtracting a value to the original, adding or subtracting will move us up or down, respectively. So that one's not too bad. Adding and subtracting, moving up and down, that makes sense. But what really is interesting when we're working with linear functions is when we multiply f of x by a value. So if we're multiplying, let's say, negative 2 times f of x. Remember, the function we're transforming is this original parent function. F of x equals x. That's the parent function, which we know we can always rewrite as y equals x. So I'm taking negative 2 and I'm multiplying it by f of x, which we are calling equal to x. So this is really negative 2 times x. So, filling in all of our values of my favorite points, negative 2, negative 1, 0, 1, 2, I get negative 2 times negative 2, negative 2 times negative 1, negative 2 times 0, negative 2 times 1, and negative 2 times 2. So those values you give me, negative times negative is positive, so negative 2 times negative 2 is positive 4. Negative 2 times negative 1 is positive 2, and I get 0, I get negative 2, and finally negative 4. So what's happening here? If I plug in these values, because remember these are coordinates, this is the coordinate negative 2, 4, this is the coordinate negative 1, 2, this is the coordinate 0, 0, and so on and so on. So if I plot those in, negative 2, 4, that's here. Negative 1, 2, that's here. 0, 0 is here. And 1, negative 2 here. And 2, negative 4 is here. So here's my new line. And I'll spoil the fun. There are two transformations that are happening, two separate transformations. The first has to do with this negative value. So let's talk about that. Well, let's look at the slopes. I didn't move my graph up or down. My y-intercept is still 0, 0. So all I've changed is my slopes. So the original slope is up 1 over 1, up 1 over 1. But my new slope is down 2 over 1, down 2 over 1. And we know down is going to be negative. So negative 2 over 1. That's my rise over run. That's my slope. So by multiplying by negative 2 by the entire parent function, I've changed the slope from 1 to negative 2. And that makes sense. So the two transformations are happening. If I separate it, the best way to think about it is like this. So let's say I'm not adding a, but I'm multiplying by a out front. Then let's have my slider back at 1. So if my slider's at 1, this is the original parent function. Well, let's say, forget the negative. Let's say I'm only multiplying by positive 2. By positive 2. Then, take a look. My slope is going from up 1 over 1, up 1 over 1, to up 2 over 2, up 2 over 2. So, the slope change happens when I make it 2. But if I make it negative 2, look at what happens. I cross the x-axis, and now I'm reflecting over the x-axis. So my slope is still 2 up, rise 2 over 1, but now it's going to be negative. And the way I think of that negative, so it's hard to see with linear functions, but what's happening is I'm taking this entire original function, the blue line, and flipping it. I'm reflecting it down across the x-axis. And the easiest way to see it is if I use a function besides my linear. So you haven't seen this yet, but let's say I make it a quadratic, so x squared. And now it's really clear that if it's a negative number being multiplied, so let's say just negative 1. Negative 1, the slope stays the same. Up 1 over 1 is still down 1 over 1, but now I flipped it over the x-axis. So reflected over the x-axis. So the two things that happened here is I transformed it by reflecting it across the x-axis, and because I multiplied it by 2 instead of any number, so I multiply it by 2, that's a number bigger than 1, so I could consider that a steeper slope, a steeper slope. And that makes sense because down 2 over 1 makes this line slightly more steeper than up 1 over 1, up 1 over 1. It's a little more of an incline. So two things happen here. Describe the effects on a linear parent function when multiplying f of x by a value. Well, the two transformations that happened. Multiplying by a negative number. So it could be any negative number. So let's say I just multiplied it by -1, then the slope doesn't change, but the transformation is a reflection across the x-axis. Whereas multiplying it by value 2, well, 2 is greater than 1. If I ignore the negative, multiplying it by a number greater than 1, so 2 is greater than 1, it gets steeper. So the next graph we're going to look at, what happens if we multiply by a number that is less than 1. Let's take a look. So here we have 1/2 times our original function. So this is going to be 1/2 times all these x values, and I don't need to show that. The only thing I need to see is that if I multiply by 1/2, my original slope of my parent function is up 1 over 1, up 1 over 1. So my old slope is 1. But since I'm multiplying by 1/2, my new slope is 1/2, up 1 over 2. Because remember, slope is always rise over run. And let's see what happens. Is it going to be steeper, or is it going to be less steep or flatter? So if instead of going by up 1 over 1, I go up 1 over 2, then I'm here, up 1 over 2, or down 1 to the left 2. Now my new line stays at the crosses at the origin, so I haven't changed my y-intercept, but my new line, it looks much flatter. So you see the slope went down flatter. So the transformation, I say, by multiplying by a number less than 1, it became flatter. Okay, so multiply by a negative number, it's a reflection. Multiply by a number greater than 1, it gets steeper. Multiply by a number less than 1, like let's say 1/2, then it gets flatter. And another way you might see flatter is less steep. Okay? So we could put these two transformations together. I'm not going to fill out these tables because that's a little bit of a waste of time if we understand what these numbers do. So like I said, two transformations are happening here. Multiplying by a number, and we are adding a number. So let's take a look. If I add a number, that's moving us up. And if I multiply by a number, well, let's see, is that number greater than 1 or is it less than 1? Well, 2, that's greater than 1, so it's going to be steeper, and it's going to change my slope from the original up 1 over 1 to up 2 over 1. So my old slope, my original slope of the parent function is always 1. Y equals x always has a slope of 1. But my new slope, by multiplying by 2, is now 2, which we know is the same as 2 over 1. Rise 2 over 1. So adding this plus 1, that's going to move us up 1. And multiplying by 2 will make us steeper because it's greater than 1. So let's take a look. Let's move up 1 first. That's here. And having a new slope of 2, that's up 2 over 1, up 2 over 1, down 2 to the left 1. My new line does in fact look like it's getting steeper. It had to rise above this y equals x line. So I moved up 1, and I can tell that because my new y-intercept is 1 higher, but it's also slightly steeper of an incline. It'd be harder to climb up. So let's look at this one. Here I have two transformations. I am multiplying by -1. So the negative, let's see, if I multiply by a negative, I'm going to have a reflection. So the first thing I should write down is the transformation. Because of this negative, it'll be a reflection. across the x-axis. But since I'm multiplying by -1, I ask myself, is 1 greater than 1? Is 1 less than 1? No. 1 is 1. The slope hasn't changed. So no slope change. It does not get steeper. It does not get flatter. So it's just a reflection. But adding 2, remember we said adding is the same as going up. So we are going up 2. So reflection means I'm going to flip this graph across the x-axis. So I know it's going to look like a reflection, but I'm also moving up 2. So let's move my y-intercept up 2 first. So up 1, up 2. That's my new y-intercept. And now my slope will go from 1 to -1. So it doesn't get steeper or flatter, but it does flip and reflect. So down 1 over 1, down 1 over 1, up 1 to the left 1. And it looks like this. A reflected slope, but it's been moved up 2. Okay? So looking at this line, or this equation, I have 3 transformations that are happening here. The first transformation, negative, that's a reflection. The next transformation, multiplying by 3. Remember, if it's greater than 1, it makes it steeper. And finally, adding 2 is going to move us up 2. So I look at my blue line. I definitely reflected, so now I have a negative slope. It moved up 2, so here. And now I have a slope of 3 over 1. So down 3, 1, 2, 3, and over 1. A much steeper slope. And hopefully that's enough to help you. If there's any other questions, please email me. I'm always here to help.